We're going to do in this video is to learn how to handle that of the missing values. Know that most of the times when we get our data might not be complete. There might be some missing values that we need to actually set in. Maybe we need to actually compute, or maybe we need to actually one way or the other try to strategize to actually fill up the missing value, because most models don't actually understand, tend to I can say overfit, underfit our data because some values are missing. So, and if a whole lot of values are missing on your data, it can make your data to become really noisy and messed up. So that's basically what we are going to do in there. There are basically two ways where we can actually do this. There are many other ways, but we're going to make use of one of the two best way that it can be done using this of the Sklearn. Remember, in our pandas tutorial, where we make use of pandas to do Python data analysis, we actually learned so many ways to actually handle missing values. So let me just comment this out. I don't want us to make use of this data to actually for the video. I have a data. Let me just let me come down here, let me paste this here. So I want us to make use of this data, which is this data. I have that of the age, colon, and with its values. Then we need to import actually numpy, because we make use of numpy to actually set, you can say import our numpy as NP. So if we import this numpy as NP, remember that you can give it a name of your choice. So we just made use of numpy to actually set this of our num values. You remember, you can actually set it's not a must. You can actually come here and set num. This signifies this is actually a num value, but or you can just make it an empty string. But let's just do it in one of the best way that is being done, because setting is as a num value. We know that a num value actually means not a number. That's actually what it means. So let's actually print out our data frame on the screen, which is our, remember that this is actually where we stopped on our previous video. This was actually this of the Titanic data set that we actually loaded and printed out only that of the 5 rows. So let's actually run this to see our current data. Remember that we selected this of our Titanic data set. So let's actually see our as we can see here, we have this of the age colon that we have here. This is the 25, 27 for this of the colon, and this of the salary colon, and this of the experience colon. No, on this of our age colon, we have this of the num value that exists on it, and for this of our salary, we also have this of the num value that exists on it, and for this of our experience, we also have that of the num value that exists on it. So how can we handle this of the num value so our models can understand this of our data? So like I explained in our pandas data analysis, if your num values, or you can say num values, are not really much, you can spare them, you can get rid of them, so we can focus more on that of the available data. But in a situation whereby the num values are really much, and at times if num values, the best is just to get rid of them. But in a situation whereby you can sacrifice that of your num values, rules, you can actually handle them in so many ways. So the one of the first way we can actually handle them with this of the Sklearn is for that of the SimpleImputer and that of the KNN-imputer. These two guys are really good. But SimpleImputer is just basically going to, they have a parameter which is actually called that of the strategy. So you can start to set a strategy. Strategy can be that of the mean, median, mode, and frequency distribution. But that's of the KNN-imputer, which is actually make use of that of the n neighbors to actually find the closest can say the closest missing value. This KN tend to be more broad when it comes to his own side of the computation. So we can say from this of our Sklearn, Sklearn import from our Sklearn impute. This of our impute, to want to import want to import our that should be SimpleImputer, and that of the KNN, which is actually KNN-imputer. Thank you, VS Code, to just complete some of these guys for me. So now we have the SimpleImputer and that of the KNN imported. So we are going to see how we can actually apply these two guys. So let's actually call this of our let's just call it original. So I'm just going to, so we won't get this. So we know that this is our original data frame that we have here. So the next we want to apply this of the, first of all, we want to apply this of the SimpleImputer. So we can say our model, you can call it, let's start with this SimpleImputer. And this SimpleImputer have other parameter, but we're just going to make use of that of the strategy, which is strategy. You can set that of the strategy in case if you are interested in that of the mean, if you are interested in that of the median, if you are interested in that of the mode. But let's also go for the mean. This mean tend to be do a little bit better. So what we want to do is actually to fit it and data and that of the transform our data. So we can say our output. We can say our output is going to be this of the model fit underscore transform, and what we want to transform, which is this of our data frame. We need to actually transform our data frame. And one thing you should know, that when we say fit and then fit underscore transform, what fit actually means is for our model or what we're actually working with to actually understand the patterns in our data, because this fit transform just like, so this fit is basically what fit actually does is to learn patterns in our data, how our data, to learn other patterns that exist within this our data, and this transform is to make use of this pattern that it have actually learned from our data to actually apply it and then to get our output. That's basically what this fit actually does, and this is basically what fit and does transform actually does. So combination of these two guys to just make it everything in one go, just like a shortcut to actually get these guys. So we can actually try to print our output in case if you want to see your output. Like I said, what it actually does is just basically to simple. What actually does, it's going to all this of our age is going to do what the mean of for this of our age is going to compute it here. So for this our salary, the mean is going to compute it here. So the experience, the mean 1, 2, 3, 4 divided by 4 is what going to get our experience. So let's just actually wait for it to load. So the next after that, so we are going to actually make use of this SimpleImputer to actually see example. I remember one thing you should also keep in mind is this. Remember that these guys, this SimpleImputer KNN imputer, what they actually handle is that of the numerical values. When I mean numerical value, I mean numbers. You don't expect to come and put maybe something like easy here and you expect it to actually compute it. No, it's going to have an issue, because with the parameter that is being set in place, it's actually handle that of numerical values like numbers and numbers like integer floats. So you don't have a test on your data and you want to do this, make use of this SimpleImputer by setting the strategy to mean it is not going to work. You are going to run into an error, and also for that of the KN-imputer, going to run into an error. So as we can see here, this is the output we got. This is just basically, remember, let's look at this salary guy. This is the salary row. You can see it's been filled already by making, as you can see here, the value of this has been actually been filled because this is the output that we got. So let's actually set it back to our new data frame. When we set it there, we are going to actually visualize it really more. So let me just comment this out. Say our new underscore df is going to be our pandas data frame. So if you are still confused of what we actually did here, this is how to just to read your data, because this is actually two-dimensional data. So you can actually, these are each of the column that we have here, which is that of the A salary and that of the experience. So we can actually set that of our output to be inside of this place, and then we can set our columns to be that of the df columns. This is what we actually did here. The output which is these guys that we have here is going to be, and the colons, we want to give them colons, and the colon that we want to give them is going to be this our age, salary, and the experience, which is this of the is stored inside of this of data frame. So we can actually directly call our data frame dot colon. So if this is actually confusing you, you can actually check my videos on that of the pandas, make use of pandas to actually do some data analysis. We came in contact with all these things. So if you have actually watched the video, this is not going to be anywhere hard for you to actually understand. They are basically simple. So this is our origin. Okay, sorry. So let's say, let me print it out. So we actually we'll see our original data frame and that of the computed and that of the output when we make use of this of our SimpleImputer. So the next thing we are going to make use of, once we see the output, the next we are going to make use of that of the KN inputer. Then we are going to compare the difference between these two guys, like I've explained initially, that how this strategy, because we set the strategy to be mean, we can see that when we come to our age colon, initially row 2 was actually missing. Now it's being given 31. What is actually this? It computed this of the this of the first element, second element, third element, fourth element, and they divided it by a total number of 4, which is actually to get out of the mean, and that is you actually get this of the 31. So if we are to do a manual, we can just come here and go to our, let's search for our calculator. So in this of our calculator that we have right here, so let's actually compute for this of the age. Then we'll have that of the 25, we'll have plus 27, we'll have plus 35. Remember, we're going to exclude this one because it doesn't exist. Plus 35, and then we'll have this of plus 40. And then I have 127, and then divided by 4 because there are 4 elements. I'll have 31.75. So you can see 31.75, and then the same thing for the salary. The row 3 was not exist, so this 56 was actually being computed for. For this experience, the same thing also happened here. So that's just basically how this SimpleImputer. Remember that you can set that to the median. If you're interested in the median, you can set that of the median. If you're interested in that of the mode, you can set that of the mode, and also have that of the frequency distribution. So the next thing we want to actually make is this of the KNN, just like KNN imputer. This KNN imputer has I can say a parameter which is actually called that of the n_neighbors. So this is basically being used. Most of the time you can set it to 2, but default is being set to 5. How this actually KN neighbors actually work is that when it comes to this of the KN neighbor, it doesn't work like how this of our SimpleImputer that works. How KN neighbors work is that when it comes to this particular, let's say this is the missing row for this of the age. What it's going to do is that it's going to look for the closest element to it, which is the first case is going to be this of the row 1, and then does this row 1 have salary? Yes, it exists. And have experience? It exists. Then the closest element that next to this of the 2 is going to take that of the above and that of the below, because we set it to that of the 2. So in this, because our data is a little bit small, so we don't want it to actually go really much. So and this of our it's going to go to the next element for this of the age, which is 35. Does it have salary? Yeah, it does not have, but it has that out of experience. So if there are a whole lot of other data that is, it's going to actually check some other things, and then it's going to compute. Because of this of the k neighbors, it uses it to find the missing value. The mathematical computation for this is really complex and complicated as entire, but we're just going to look and see how we can actually make use of this guy. So just by setting this KN imputer and the neighbors to be that of the 2, you can start to leave it as default, which is actually that of the 5, which is actually a good which is actually good. But since our data is a little bit small, so we can actually just set it to that of the 2. We have the output. They are just basically the same things. Remember that if we are to solve this manually, this is actually going to take a whole lot of time to actually solve. So with the help of this Sklearn library, which is this guy, it makes things a little bit easier for us. So if you are really interested in want us to solve this of the KN-imputer manually, just let me know in the comment section down below. The formulas are quite make use of that of the Sklearn distance to find the distance between each of the two values that appear before that of NaN and after that of the NaN value. So let's look at this. When he actually did this, when he actually found that of the when it's actually of the missing value, like I will know this of the 3 for this of the salary was not easy, so we got 60, and for this of the row 2 for this of the age, I got that of the 31. Remember when we use that of the SimpleImputer, we got something like 31.75 or so, and for this of the experience we got this 35. So the way SimpleImputer and KN-imputer handles the missing value, they differs completely from each other. They are not the same. So the use case of each of them comes to your own taste, because most of the time KN-imputer might be the best and one of the smarter way to actually handle missing value. But the problem with KN-imputer is that it can be slow to actually do all these guys, because don't think because I have small amount of data, just three columns, I can say 3 features with just no more than 5 rows. You don't actually think that KN-imputer is quite fast compared to that of the SimpleImputer. SimpleImputer tend to so don't think that this simple KN-imputer just works really fast. At times it can be really slow depending on the size of your data. So I think this is actually conclusive for handling of missing data by making use of that of the SimpleImputer and KN-imputer. Of course, there's still a lot of things that we should have actually covered, but I think let's actually keep it simple to this. But if you want the complex part, just let me know in the comment section down below. I'll be happy to actually dive in more onto of this KN-imputer, because this KN-imputer most times, like I said, is one of the smarter way to actually handle that of the missing value. So I think this concludes it for this video. In our next video, what we are basically going to do is that of the future scale. Most of the time when we look at this of our salary, age, experience, they don't really tend to actually look anywhere close to each other. You can see the salary 50,000, 54, 58, and the experience is just 1, and the age is just 25. You can see some machine learning model like logistic regression can treat some features as a higher higher importance compared to the other ones, even though each features contribute to that of the target. But that's what we are going to handle and talk more on this of the feature scaling and feature normalization. That's basically what we are going to do in the next day. So if you find this video anywhere useful, subscribe is not going to be a problem. So I'll be happy to see you in the next video. Thank you.